Hello everybody, welcome to the rest of the video notes for section 3.3 in Precalculus, aka properties of polynomial division. So we'll look at synthetic division, the remainder, and factor theorem to start here. Now that polynomial division is out of the way, synthetic division can be explained. Despite its name, synthetic, aka fake division, actually divides polynomials, but it won't feel like it. Synthetic division can only be used if the divisor is in the form x minus c. And I should say synthetic division is easiest if the divisor is x minus c. You can actually divide by a linear polynomial if the coefficient is something other than 1. That takes a little bit of explanation, and I will not be going over it here. Anyway, below are some steps to set up and complete an exercise using synthetic division. So the first thing you want to do is set the divisor equal to 0 and solve and put the result in the corner. So really, this is the divisor over here. X plus 4 equals 0. That means x equals negative 4. And I say just put that in the corner like this. The second step says bring down the coefficients of the dividend. So you can see there's a 1 in front of the x cubed, a 2, a minus 3, and a 20. So the 1, the plus 2, the minus 3, and the 20 come down. And then additionally, step 2 will have this line added here. So all of this was step 2. All of this was step 1. To synthetically divide, how that will work is you will just bring down the first coefficient. So synthetically dividing here, we have a 1. Now, to progress through the rest of the columns, you can pretty simply just take this number, the negative 4, and you're going to multiply it to this 1, and you're going to get a negative 4. So what we did there was multiply, and then we add the two numbers in the same column now, the 2 and the minus 4. So that's going to be a minus 2. And then we just keep doing this process. Negative 4 times negative 2 will give you negative 8. From there, we can combine these to be negative 11. Then we can do this multiplication again to get 44. And then you can add these two numbers together to get 64. And we're done. We don't have any more columns to go to the right of 20. And then we have these numbers here, right? We did this work to come up with this answer. What does this represent? Well, at the beginning, we had x to the third power, x squared, x, and a constant. And what synthetic division does is it takes one power away from each x. So these down here will be x squareds and x's and constant, and this last number is the remainder. So going from the last video, how do you write your answers? Well, this will be 1x squared minus 2x's minus 11, and then the remainder gets added on, and that is a 64, and you will divide that by the divisor that is way back here, x plus 4. And this is the answer. Now, if you had to separate out as the quotient and the remainder, again, this part in green here is the quotient, and the top part of this fraction, you can see it in this box here as well, is the remainder. So why is it important to know how to synthetically divide? Well, it turns out that with synthetic division, we can immediately, without a whole lot of work, find the remainder of a division without actually doing the synthetic division. This is kind of a cool little thing here. The remainder theorem states that if the polynomial p of x is divided by a linear divisor, then the remainder is p of c. C is what you get when you set this equal to 0 and solve for x, right? It would be x equals c. So what that means is that you can find that value and just put it in the function and bam, or the polynomial that's being divided, like the top one here or the front one here. And you can just tell what the remainder is. And that's nice because of the factor theorem. If the perceived 0, the solution for this divisor, when you substitute it into the polynomial and get 0, then that divisor is a factor of p of x. And this works in reverse too. If this is a factor of the polynomial, then the 0 it creates will create 0 when you substitute it into the polynomial. Let's see this in action. The question is, what is the remainder of the division below? I have no idea. But if we take the divisor and we set it equal to 0 and solve for x, you'll get x equals 2. What that means then is if we call this top polynomial f of x and we find f of 2, we know what the remainder will be. This is 5 times something to the 5th power minus 7 times something to the 4th power minus 62 times something to the 3rd power. And what you can do here is really just type this in all on a calculator. Show this step to make sure I understand you know what's going on, right? You're going to substitute it all in. And then from here, this is a calculator problem. So just put it in the calculator and you'll get that f of 2 is 0. So that's the remainder. We can prove it using synthetic division really quickly. We already know that x equals 2 is what goes in the corner. And you can see the coefficients here of 5, negative 7, negative 62, 52, 98, and 44. So the first one that comes down will be 5 times 2 is 10, add those together is 3, times 2 is 6, add those together is minus 56, times 2 is, what is that, negative 112, add those together is 60, sorry, negative 60, times 2 is negative 120, add those together is minus 22, times 2 is negative 44, which is 0. All right, we got it. So we can see that this works now. And you type this all in the calculator and get 0, and the remainder was 0. How does that help us? Well, again, if the remainder is 0, that means x minus 2 evenly divided this polynomial in the top. So what that means then is we could write f of x as x minus 2 times, right? It's a factor of that, whatever was left as part of our answer. So that becomes 5x to the 4th plus 3x cubed minus 56x squared minus 60x minus 22. And you are now factoring with a completely new method, right? We took this really ridiculous polynomial that doesn't look like it should be factorable at all. We divided it by this pretty innocuous linear factor, and it worked. We got a 0 remainder. This was our answer. Will that work with example 3? Well, let's take a look. All right. We can set this up. We can say that this is p of x, which is what I should have used in the last example, p of x. And this is the divisor. So if we set this up here very quickly, this is a P of, if we set x minus 2 equal to 0 and solve, that means x equals 2. Oh, again, huh? Weird. All right. So negative cubed plus 4 times plus 6. Okie dokie. So we can put 2 here, 2 here. And what we end up with here is P of 2 equals 6. So this will not be a divisor, but let's just use synthetic division really quickly to see if this is what actually happens here. So let's say x equals 2. Let's do negative 1, suspiciously spaced 4, and a 6. So this brings up something that I covered in the last video, is that every power of x needs to be represented, right? There's a 3, there's no x squared, there's x to the first, there's a constant. So what that means is wherever those x squareds are, you need to have a 0 in its place. All right, just don't forget that. That'll be a very bad day for you. So negative 1, we can bring it down, times 2 is a negative 2. We can add these together to get minus 2. We can add multiply the 2 times negative 2 to get negative 4, which is 0. And then lastly, we can say 0 times 2 is 0, and the remainder is 6. That is exactly what we found up here. And that means x minus 2 is not a divisor of this over here. Okay, that's it for synthetic division. Catch me in the last video to finish up this set of notes.